Okay, this time I'm going to talk about elasticity, and I'm going to start by showing some graphs. I start with this table, price, quantity demanded for those prices, and the quantity that would be appropriate for marginal revenue. We know from mathematics that marginal revenue has twice the slope of the demand curve, and for each price then the quantity would be half what it is for demand, okay? And total revenue is equal to price times quantity. So over here, I have graphed those things. Here's the demand curve, and here is the marginal revenue curve. Now notice that the marginal revenue curve does hit the axis at the halfway point. This value out here is 700, this one's 350. So whenever you're graphing marginal revenue on a demand curve, it has the same vertical intercept here and then crosses halfway down the x-axis. Now, this demand curve now is split in two. On this half is the elastic region where when I lower price, total revenue will increase, and on this half is the inelastic region where when I lower price, total revenue declines, and the reverse is true of those two statements. The absolute value of elasticity when I calculate it will be greater than 1 in this elastic region, and it will be less than 1 in the inelastic region. Now, the other unique thing about these graphs is that I've tried to line this one up with the axes here as best I could, but this line I drew in shows that the marginal revenue equals 0 and the halfway point of the demand curve and the maximum of the total revenue curve all are on this line. So total revenue is maximized whenever marginal revenue equals 0. But now look, if I'm on this side, the elastic side, if I lower price from here to here, I see the total revenue increase. On this side, if I lower price from here to here, total revenue declines. The reverse is true. Raise the price from here to here, total revenue increases. So I have a way to graphically look at what I can do to optimize my pricing. We don't have a firm trying to maximize their total revenue. Their job is to maximize their profit, and that's a different thing. But we do need to know in what direction can I go in my pricing to increase my revenue. So this is how it is done. Now we need to calculate these elasticities using mathematics. Okay, here's the equation for arc elasticity, which is the elasticity between 2 points. What is the value? The average elasticity moving from one point to the next. That's a big cumbersome equation. The difference in the first and second quantities divided by the average of the two. Divide that by the difference in the price of the two quantities. Prices divided by the average price. So I tried to break this down, simplify it a little bit. I have quantity 1, quantity 2, price 1, and price 2. So here in this example, I picked a price of 6. I go up to the table, a price of 6 is a demand of 100. So my first price is 6, the demand is 100. Next one is 4 from the chart up above, the demand is 300. Q2 minus Q1 is 200. I put a formula in there for that. Same thing down here for price. Then I have a formula for this one, which is the average of the two. And then over here, I get the top, the numerator part of this equation. Difference in quantity divided by the average quantity. And I've got a formula for that. And over to here, I now take the final formula, which is the top number divided by the bottom number, and I get minus 2.5. So, what is that telling me? If my price were $6, if I would move from $6 to $4, the average elasticity, or the arc elasticity, would be minus 2.5, which means that I was in the elastic region. So I should expect total revenue to increase. Okay? So let's try another one. Let's pick a price of 3 as our first price, and a price of 3 is a quantity of 400. And let's go to our second price, make it 4, price of 4. For my second price, I already have that. Cool. So let's see. Price of 3 and a quantity of 400 and a price of 4 and a quantity of 300, my price elasticity is -1. Okay? That means that in that move there, I went from price of 3 to price of 4. The average of those 2 points for elasticity is that arc elasticity, which is -1. So I crossed, on average, across the maximum revenue. Okay, now point price elasticity is a different concept, but very, very similar. Here we've actually picked the elasticity at a particular point on the curve and not some distance between the two, but one price, one quantity. What would the elasticity be at that exact point? This is where mathematics comes in. Mathematics tells us that the elasticity of price, notice that's the small e versus the large e up there for arc. The elasticity of price is the change in quantity divided by the change in price times the price you select by the quantity that matches it. Now the change in price over the change in quantity is the slope of the demand equation. And demand equation is in this form. Quantity equals A minus BP. Now in this particular example, I don't have the equation for that chart. I don't know what it was that created it. I can figure it out, but I don't know what it was. But over here on the Excel, I can click this here and it'll ask me, give me the opportunity to format the trend line, and I told it to display the equation for that line on the chart, and it did it right here. Now this is the inverse demand equation because, as I told you before, we always put price in economics. We always put price on a vertical axis. The demand equation is written Q equals A minus BP, but the graph is P equals A minus BQ. So this is price equals 7, that's the A, minus B, which is 0.01 Q. So that is the inverse equation. We want the actual demand equation. So fortunately for us, mathematics tells us that if I divide 1 by the slope here, I will get the slope of the inverse. So that'll be the number I want. 1 divided by 100 is the slope of the demand equation in the form Q equals A minus BP. Here is the price I've chosen, 3.5. The quantity I've chosen is 350. When I do the calculation, it's -1. So I picked the exact point, 3.5 and 350, where the elasticity is what's called unitary, equal to 1. And that is where total revenue is maximized and where marginal revenue equals 0, and it is the halfway point of the demand curve up above. So let's pick another one just for kicks. Let's say 2 and 500, 2 and 500. A price of 2 and a quantity of 500 is minus 0.4. That tells me at a price of 2, I'm very inelastic. I want my elasticity to be closer to 1. So in this situation here, it would behoove me to raise my price, and my elasticity would increase, and my total revenue would increase. Okay, so I hope this helps you understand the concepts of elasticity. Elasticity is nothing more than a measure of the sensitivity of two variables, price and quantity in this case. Okay, thanks.